At 3:28 in the morning on January 11, 2023, a contractor sat down at a workstation inside a Federal Aviation Administration facility. His job was routine: synchronize a database, make sure the backup matched the primary. The kind of maintenance that happens quietly, every day, across thousands of systems you've never heard of. He replaced one file with another. He didn't realize he'd made a mistake. 4 hours later, every commercial flight in the United States was frozen on the ground. 11,000 flights delayed, 1,300 canceled. It was the first nationwide ground stop since September 11, 2001. Not because of a terror attack, not because of weather, not because of a cyber attack, because one engineer in the middle of the night copied the wrong file. Before any pilot in the United States takes off, they read a list. It's called a NOTAM, a Notice to Air Missions. It tells them everything that's different about their flight today that isn't on the regular charts. A runway is closed for repaving. The lights on a navigation tower are out. A presidential motorcade is creating a temporary no-fly zone. There's a flock of geese near Cleveland. Construction equipment is sitting too close to a taxiway in Tampa. The FAA issues more than 4 million of these notices every year. The system that distributes them sounds boring. It is boring. It's just a database that pushes text messages to pilots and dispatchers. No radar, no flight tracking, no air traffic control. But here's the thing. Federal regulations require pilots to review current NOTAMs before every flight. If the system goes down, pilots don't have legally valid safety briefings, and without those briefings, planes can't legally fly. That's the chain. A boring text database sitting quietly in the background holds the legal authority to keep the entire commercial aviation system running. When it broke, the FAA had no choice: ground everyone. To understand why a single mistake could take down the entire system, you have to understand how old it actually is. If you enjoy learning how the hidden systems behind modern life actually work, from power grids and water infrastructure to transportation and emergency networks, consider subscribing to Engineering Your World. Because the more you understand how these systems work, the better prepared you are when they don't. The U.S. NOTAM system was built in 1985. To put that in perspective, when this software was written, the Berlin Wall was still standing. The first version of Windows had just been released. Most pilots were still receiving NOTAMs on paper teletypes, and the system has been patched, extended, and bolted onto for 40 years. Here's how it was supposed to work. There were two databases, a live primary that everything ran on, and a backup that mirrored it. If the primary failed, the backup would take over. This is called redundancy. It's the foundational principle of building reliable systems. Two of everything. If one breaks, the other one keeps you running. But there was a flaw in how this system's redundancy was designed. The two databases weren't truly independent. They were continuously synchronized, meaning anything that happened on the primary was copied to the backup, including mistakes. Think of it like having a spare set of car keys that are magnetically linked to your originals. If you lose your original keys, the spares vanish at the same time. That's not actually a backup. That's a copy. And on the night of January 10th, the contractor at the keyboard was doing exactly the kind of work this design couldn't survive. The contractor was an employee of an FAA contractor. They were the first-tier technical support team for the NOTAM system. Routine database maintenance was part of their daily job. That night, they were synchronizing the live primary database with its backup. The two had drifted slightly out of sync, and the procedure was to align them. According to the FAA's investigation, the engineer replaced one file with another. The FAA never publicly specified exactly which files or what the difference was, but the result is clear. The file that replaced the original was corrupted, or incompatible, or simply wrong. And because the two databases were continuously synchronized, the corruption spread immediately to the backup. The redundancy didn't save them. The redundancy made the failure twice as bad. By the time anyone noticed, both copies of the database were broken. The FAA tried to restart the system. The reboot failed. By the early morning hours of January 11th, NOTAM stopped publishing new notices entirely. Airlines started calling. Pilots couldn't get their pre-flight briefings. Dispatchers couldn't release flights. At 7:30 a.m. Eastern Time, the FAA made the call: ground stop. Every domestic commercial flight in the United States frozen in place until the system could be brought back online. It took until 9 a.m. Eastern to fully restore service, about 90 minutes of formal ground stop. But the cascade had already happened. 11,000 flights were delayed. 1,300 were canceled outright. The ripples kept moving through airline schedules for days, all from one file. The NOTAM outage exposed something that good systems engineers have understood for decades, and that this particular system had quietly violated. Real redundancy isn't just having two of something, it's having two of something that fail for different reasons. A good redundancy looks like this. Your primary system is software-based, running in a data center in Virginia. Your backup is a different software stack, running in a different data center in Oklahoma. They share no code, they share no network, they share no operators. If one fails because of a software bug, the other one keeps running because it doesn't have that bug. That's called fault isolation. The whole point is that a single mistake can only break one of them. The NOTAM system's backup wasn't isolated. It was a mirror, the same code, the same data on the same network, maintained by the same people, synchronized in real time. When the primary got sick, the backup caught it instantly. And this isn't unique to NOTAM. It's a pattern that shows up across critical infrastructure. The 2017 AWSS-3 outage that took down a huge chunk of the internet was caused by an engineer typing the wrong command during routine maintenance. The 2021 Facebook outage that erased the company from the internet for 6 hours was caused by a configuration update that locked engineers out of the systems they needed to fix it. The pattern is the same. A system gets old. Maintenance gets routine. Routine gets careless. And the redundancy that's supposed to protect you turns out to be tied to the same fate as the thing it's backing up. In aviation, these are known as single points of failure, the components in a system where a single mistake can bring down everything that depends on them. Modern aircraft are designed to have 0 single points of failure. The system that tells the aircraft when it's safe to fly had at least one. After January 2023, the FAA didn't just patch the existing system, they started replacing it. Congress passed the NOTAM Improvement Act of 2023. The FAA established a task force in early 2024, and in 2025, they awarded a contract to a company called CGI Federal to build the system's replacement from scratch, running on Google Public Sector's cloud infrastructure. The new system is called the NOTAM Management Service. It went live in late September of 2025, running in parallel with the old system. The legacy 1985 software is scheduled to be fully retired by spring of 2026. The architectural difference matters. The new system is cloud-hosted, which means it doesn't run on a single physical server somewhere. It runs across geographically distributed data centers with true fault isolation between them. When one node fails, the others don't automatically inherit the failure. It's also designed to be human error resistant. Database changes go through review processes. Maintenance procedures are tested in isolated environments before touching production. The kind of single keystroke mistake that brought down the old system would have to bypass several layers of automated safeguards in the new one. Will it be perfect? No system is. But it's no longer a piece of software that was written before the World Wide Web existed, holding the legal authority to keep American aviation flying. There's something uncomfortable about the NOTAM outage. It's not that a system failed. Systems fail all the time. It's that the system that failed was so unglamorous, so deep in the background, that almost no one knew it existed, and yet it had the authority to ground every commercial flight in the country. That's how critical infrastructure usually works. It's the systems you've never heard of that holds the whole thing together. And the ones you've never heard of are often the oldest, the most patched, and the most fragile. The good news is that sometimes it takes a public failure to finally get the funding and the political will to fix something that engineers have been quietly warning about for decades. The NOTAM outage was that kind of failure. Embarrassing, expensive, and, by accident, exactly the wake-up call the system needed. If you like this video, you might enjoy our episode on what happens when GPS fails, another invisible system that almost no one thinks about until it doesn't work.